In this video, we'll be discussing the mean of discrete random variables, also known as expected value. Let's start by discussing the average again. We're all familiar with the idea of mean or average. Let's say I've got the numbers 0, 1, 2, 3, and 4. If I wanted to find the average of that, I'm just going to simply add up all those numbers together and divide it by the number of digits that I've got. So in this case, I will do 0 plus 1 plus 2 plus 3 plus 4, and I'll divide it by the number of terms there are. And in this case, there are 5 numbers altogether, and that leaves me with 10 over 5, which is equal to 2. Straightforward. Alternatively, I could have actually multiplied each one of these numbers by 1 over 5 individually and then added them all together. So I could have 0 times 1 over 5 plus 1 times 1 over 5 plus 2 times 1 over 5 and so on. And adding all of that together, it also leaves me with 10 over 5 and my answer is 2. So this is like saying that each one of these numbers has a weight of 1/5. There are 5 numbers, so each one of these numbers has a weight of 1/5. So let's discuss that a little bit further. Now let's change the weight of 1 to 0.6, and we'll bring down 0, 2, 3, and 4 to 0.1, and I've made sure that they all add up to 1. If I now find the weighted average here, I will do 0.1 times 0, 0.6 times 1, and I'm adding them in between, plus 0.1 times 2, plus 0.1 times 3, and plus 0.1 times 4. This gives me 1.5. So the weighted mean is now actually a little bit lower to what it was before. This has been pulled down by the weight of 1. So what this means is when the weights of some values change, so does the central point, and that central point being the mean. So as we've just seen, the weighting of a value is just the value itself multiplied by its probability, leaving me with x times p of x. Now we need to add up all these products for all the values in the distribution, and I'm going to use the symbol sigma here for taking the sum of all of these products. So thus we've got the formula here is the expected value, E of x is equal to the sum of x, so that's your value, times its probability. Now depending on what resources you're looking at, you can also write the expected value as mu times x. So you can just plug in all your products into that formula and add them up. I find that it's actually easier to look at it in table form. Looking at an example, I've just put a table together and it represents the number of heads that appear after tossing a coin 4 times. So now if I wanted to find the expected probability, it's just visually easier to see it this way. So I'm just going to do 0 times 1 over 16, that gives me 0. Then I'll do 1 times 4 out of 16, that gives me 4 out of 16. 2 times 6 out of 16 gives me 12 on 16. 3 times 4 on 16 gives me 12 on 16. 4 times 1 on 16 gives me 4 on 16. Now the sum of all of these probabilities here is 1. And my expected value is 2. In this example, we have 20 friends have gone out to dinner at a restaurant. 1 has $60 in cash, 3 have $340 in cash, 2 have $220 cash, 4 have $100 cash, another 4 have $50 in cash, and 6 have no cash. A thief steals one of the friends' bags and takes off. Graph the distribution and expected criminal gain. So I'll start by putting in all that information into a table where I'm going to set my values to be the amount of cash that each friend has and the respective probability. So I've ordered these values from smallest to largest. It does not matter the order whatsoever. The probability of one of the friends having no cash is 6 out of 20. The probability of a friend having $50 in their bag is 4 out of 20, and so on. Now I'm going to multiply these two together, and for 0 times 6 on 20 I get 0, 50 times 4 on 20 I get 10, 100 times 4 on 20 is 20, 220 times 2 on 20 is 22, 340 times 3 on 20 is 51, and 600 times 1 on 20 is 30. To find the expected criminal gain, or expected mean, I'm going to use this formula where I need to find the sum of x times p of x. Now I've got them all listed here in the table, so I'm going to add all those values together, and I get $133. Now remember, this $133 does not represent one of these x values. It is the expected mean, so the theoretical mean. Now graphing this distribution will be done as such. So I've just put the table up there again, and I've just got my probability on my y-axis versus my values here on my x. You can see I've put them here in decimal form, and I just did that to show that it actually doesn't matter. I could have kept my axis in fraction form or in decimal and it would not have mattered. And you can see for a value of 0, the respective probability is 0.3, which is the same as 6 on 20. I've got my $50 and $100 are 4 on 20 or 0.2. and so on. And you would just leave it like that. So now suppose I want to find the expected mean for x squared. All that means is I just need to find the sum of x squared times the probability. So I'm just going to square each of my values and then I'll multiply it by its probability. So in this case, I'm going to do 0 squared times 6 over 20 plus 50 squared times 4 over 20 plus 100 squared times 4 over 20 and so on. And that leaves me with $42,680. This was just based off that previous example. If you enjoyed this video and found it helpful, please don't forget to hit the subscribe button before you go. And also check out our social media pages across all the platforms under Ask Cassie.